Hi, welcome back to this video on and or graphs. So first, reading out the definition: and or graphs. And or graphs are a generalization of regular graphs used to represent problem solving scenarios, especially in situations that involve conjunctive or disjunctive decomposition of problems. Okay, conjunctive or disjunctive decomposition of problems. So, diving deeper into the definition, an and or graph is a type of normal graph that helps us model complex problems. Complex problems by breaking them into smaller subproblems, manageable subproblems. Okay. In simpler terms, or nodes represent alternative choices. Solving any one of the subproblem is enough. And node represents combined requirements. Solving all problems is necessary or mandatory. Or nodes represents alternatives. One of the option would be fine. And nodes on the other hand represents dependencies. Okay. We need to solve all the children to complete the task. We need to solve all the children to complete the task. Okay. Let's go through a fine example. Imagine you are building a house. The process involves building the foundation, constructing the walls, and installation of the roof. Since these steps are required, this is an and relationship. All these steps are mandatory for building a house. Building a foundation, first step; building the walls, second step; building the roof, third step. All these are mandatory and dependent. So these are and functionality. Okay, and relation. But choosing a roofing material, when it comes to choosing a roofing material, we might have two options: tiles or normal metal. Okay. So choosing a roofing material, we can opt for first one is tile or normal metal. This would become an or relation. Or relation. You need only one. So which one is better? We need to take the decision. So here all these are in and relationship. When it comes to installation of roofs, these come into or relation. Comparison with traditional graphs. Okay. So first we'll look into what is and or graph now. For example, let's start with the node A. Then coming to next node is B. From A we are going for another node, that is C. And from C we are going to two other nodes, that is D and E. So A to B becomes an and relation, because to solve A, B must be solved. To solve A, B must be solved. Okay. So this is an and relation. Next, whereas to solve C here, we can solve any one of the child nodes. Okay, to solve C, we can solve either D or E. Okay, this is the and or graphs. So what happens in traditional graphs? Traditional graph is like, it looks like A, B, D, C, so on. So a node represents a state or a problem here. A node represents a state, or it can be named as a problem. Edges represents transition between the states. So these all edges represents transition between the states. Okay, edges represents transition between states. This is the traditional graph. Okay, traditional graph. Here and or graphs, nodes still represent problems. Nodes represent problems or goals, but the structure is different here. The structure is different here, and the structure is different in and or graphs. The structure are different. Independent and dependent sub goals using. Here in and or graphs, we have independent, this is independent, and this is dependent sub goals. Okay, I hope you understand, because to solve A, B should be solved. This is a dependent sub goal. To solve C, either D or E would do. So this is independent sub goal. Okay, this is the major difference between traditional graph and or graph. Structure same as we discussed till now. Nodes represent problems or sub-problems. Edges connect a node to its sub-goals. Edges connect a node to its sub-goals. Or node, only one of the child needs to be solved here. We have seen all and node, all of the children must be solved here. Okay, this is an and. So mostly similar structure, but the concept of independent and dependent sub-goals are added in and or graphs. So what are the use cases? Artificial intelligence planning, where tasks are broken into subtasks, is one use case. Expert systems like medical diagnosis or troubleshooting, okay, is one more use case. Game trees for modeling strategies and decisions. Robotics for hierarchical task execution. All these scenarios and or graphs are used. So search algorithm. Search algorithm for and or graphs are more complex than for regular graphs, since they must account for both kinds of relations. Why the search algorithm for and or graphs are more complex than regular graph is, the reason is that they must account for both kind of relationships, that is dependent relationship and independent relationships. Okay, AO star algorithm, a best first search for and or graphs. So as it takes more time, the best search algorithm for these kind of graphs is AO star algorithm. Okay, dynamic programming for solving reusable subproblems. So this can used as where there is case of subproblems that occur repeatedly, where we can use the solution again and again. So for there, in case if there are repeated subproblems, repeated, sorry, repeated subproblems, subproblem 1, subproblem 2 and subproblem 1, similar to subproblem 1 again, we can reuse the solutions using dynamic programming. What are the benefits of AND or algorithms? Captures hierarchical structure of complex problems. This is the first and foremost scenario. Captures hierarchical structure of the complex problems. Represents both alternative and mandatory solutions. Alternative is OR, mandatory and sub solutions. Useful in automated reasoning and intelligent systems. Okay. Thank you.